There's a planet that might be made of diamond. Not on the surface, not in small amounts, but a significant part of the entire planet. But here's the problem. New data from the James Webb Space Telescope shows this world isn't just strange, it's violent.
40 light-years away, in the constellation Cancri, orbits a world that sounds like a fever dream of a jeweler. 55 Cancri e, officially named Janssen. For over a decade, this planet has held the title of the universe's most famous diamond planet. However, as of March 2026, the story of 55 Cancri e has evolved. Recent data from the James Webb Space Telescope, JWST, and updated stellar models have revealed that while it may not be a giant solitaire floating in space, the reality is arguably more fascinating and more volcanic than we ever imagined. The origin of the bling theory. The diamond planet hypothesis was first proposed in 2012 by a team led by Niku Midhusudhan at Yale. Their logic was based on two critical pieces of data. 1. High density. The planet is a super-Earth, with about 8 times the mass of Earth, but only twice the diameter. To be that heavy and that small, its interior must be incredibly dense. 2. Carbon-rich heritage. Initial observations of its parent star, 55 Cancri A, suggested it had a much higher carbon-to-oxygen ratio than our Sun. In planetary formation, if carbon outnumbers oxygen, the leftover carbon doesn't form water or silicates like Earth's rocks. Instead, it forms carbides. Under the crushing pressure of a planet's interior, that carbon would crystallize. The model suggested that up to 1/3 of 55 Cancri E's mass could be pure diamond, topped with a crust of graphite. The reality check, magma and bubbles. By 2024 and into 2026, our view of Janssen has shifted. The latest research indicates that while carbon is likely present, the planet is less of a sparkling gem and more of a lava ball. 1. The second atmosphere. One of the most significant breakthroughs of 2025 was the confirmation that 55 Cancri E has grown a second atmosphere. Because the planet orbits its star at a staggering 1.4 million miles, completing a year in just 17.5 hours, the intense radiation should have stripped away any original gases long ago. However, JWST observations have detected a thick envelope of carbon dioxide, CO2, and carbon monoxide, CO. Scientists believe this atmosphere is being constantly replenished by a global ocean of molten magma that bubbles out gases from the planet's interior. 2. The carbon paradox. While the parent star's carbon-to-oxygen ratio was later revised to be closer to our Sun's, the planet itself remains an outlier. Even if it isn't 33% diamond, the sheer heat, reaching 2,400 degrees Celsius, 4,400 degrees Fahrenheit, means that any carbon in the mantle would still exist in exotic, high-pressure forms. Beyond 55 Cancri E, other diamond candidates. While Janssen is the most famous, it isn't the only diamond in the rough. Astronomers are currently tracking several other candidates that might fit the profile even better. PSRJ 1719-1438b. This isn't technically a planet, but the dead core of a white dwarf star that was stripped of its outer layers by a pulsar. What's left is an ultra-dense ball of crystallized carbon, essentially a planet-sized diamond 5 times the size of Earth. WASP 12b, a hot Jupiter with an atmosphere containing twice as much carbon as oxygen. While it is a gas giant, its core is likely a concentrated mass of carbon compounds that would make Earth's diamond mines look like dust specks. The geochemical weird part. The most startling realization of 2026 is that a diamond-rich composition completely changes how a planet behaves. No plate tectonics. Diamond is an incredible thermal conductor, but a poor lubricant. On Earth, the movement of silicate rocks and the presence of water allow for plate tectonics. On a diamond planet, the interior would be too stiff for plates to slide. Volcanic extremes. Instead of slow-moving plates, these planets might experience point source, volcanism, where massive plumes of carbon-rich gases burst through a rigid graphite crust, creating the variable atmospheres JWST is now observing. Why it matters? Studying these carbon-rich worlds isn't just about finding space jewelry. It is about understanding the diversity of planetary evolution. Our solar system is oxygen-rich, which led to the specific chemistry that allowed life to thrive. Finding a carbon-rich system shows us an alternative path, a dark Earth chemistry where the building blocks of life, carbon, are abundant, but the environment, no water, extreme heat, rigid crust, makes life as we know it impossible. Jansen teaches us that the universe is a high-pressure laboratory. Whether it is a giant diamond or a bubbling lava world with a carbon-heavy heart, it remains one of the most extreme environments ever discovered. While the diamond label captures the imagination, the true scientific intrigue of 55 Cancri in 2026 lies in its geological violence. On Earth, the carbon cycle is a slow, life-sustaining process mediated by plate tectonics and oceans. On Jansen, the carbon cycle is a high-pressure volcanic nightmare. Because the planet is likely composed of a diamond and graphite interior, it lacks the soft mantle that allows Earth's crust to shift. Instead of plates, the planet likely features a rigid, unyielding shell that traps heat until the internal pressure becomes unbearable. When that pressure finally vents, it doesn't result in the slow lava flows we see in Hawaii. Instead, astronomers believe 55 Cancri undergoes explosive outgassing. Massive plumes of carbon-rich gases, monoxide and dioxide, burst through the graphite crust, momentarily thickening the atmosphere before the intense stellar winds from the nearby sun strip it away again. This cycle of atmospheric breathing is what the James Webb Space Telescope is currently trying to map. It creates a world where the weather forecast isn't about rain or shine, but about whether the ground beneath you is currently exhaling a fresh layer of toxic gas. Furthermore, the lava ocean on the day side is a chemical laboratory like no other. At temperatures exceeding 2,400 degrees Celsius, the distinction between liquid and gas becomes blurred. This supercritical state means the magma ocean might actually be dissolving parts of the atmosphere, creating a bizarre feedback loop where the rocks and the air are constantly swapping chemical signatures. If you were to stand on the surface, assuming you could survive the heat and radiation, you would see a sky that looks like a shimmering, metallic haze, reflecting the glow of the molten carbon silicate soup below. The weird part about the diamond hypothesis is that it fundamentally changes how we think about a planet's habitability and death. Carbon-rich worlds are likely evolutionary dead ends. Without the lubricating effects of water and the chemical balance provided by a silicate-oxygen mantle, these planets become locked in a state of permanent volcanic stasis or runaway greenhouse heating. 55 Cancri serves as a dark mirror to Earth, showing us that even with all the right ingredients for life, like carbon, the wrong proportions and the wrong environment can create a sparkling, crystalline hellscape instead of a garden. In 2026, Jansen remains the premier laboratory for studying planetary extremes. Whether it is a literal gemstone or a volcanic furnace, its existence proves that the universe's chemical diversity is far more complex and far more brilliant than the simple rocky models of our own backyard.
Thanks for watching. If you enjoyed this journey through the cosmos, hit like, subscribe, and tap the bell. And when you're ready for your next space mystery, click the video right here.